We can take a look at a typical pressure-reducing station with air valve and flow meter on the incoming upstream pressure line, a CSA per valve XLC 310/410 installed between the two gate valves for maintenance, and a filter upstream mandatory to prevent the entrance of foreign bodies. We can then change the view on the downstream part with another CSA combination non-slam air valves and CSA relief valve to protect the downstream pipe against unwanted and unexpected rise in pressure. Water covers 70% of our planet, and it is easy to think that it will always be plentiful. However, fresh water is incredibly rare and we must take care of it. We all must be fully aware that we are managing the most important resource on the planet. If we observe the variation of the flow rate within 24 hours on district of the city, or in a town, we can see how constant pressure provided by a standard perv, and this is great, but the question is, do we need this pressure during the day, or could we lower it when the demand is not so high? As an example, at night. To answer this question, we must observe the hidden water losses, that unfortunately represent a great amount, with an average percentage ranging between 25 and 60 in some cases. Hidden losses can be holes in the pipes, leaks at the joints, valves, anything that spills wear out of our pipes. By having a constant pressure all the time in fact won't reduce the water losses, that depends on the pressure itself. The representation of the container filling up and overflowing at the end is self-explanatory. We can take a look at a typical pressure management reducing station through CSA motorized pilot valve. We observe the air valve and flow meter on the incoming upstream pressure line, a power-operated controller receiving impulses from the flow meter and pressure transmitter, the CSA per valve XLC 310/410 equipped with motorized pilot installed between the two gate valves for maintenance, and a filter upstream mandatory to prevent the entrance of foreign bodies. We can then change the view on the downstream part with another CSA combination non-slam air valves and CSA relief valve to protect the downstream pipe against unwanted and unexpected rise in pressure. The controller basically receives the data of flow and pressure and has the task of changing the pressure of the valve versus the demand. That is obtained by sending 4 to 20 ms signals to the motorized pilot that acts on the spring on the pilot by compressing it to increase the pressure and vice versa. Therefore, if we observe the variation of the flow rate within 24 hours, we can see how the pressure is changed according to the increase of decreased in demand, with the effect of optimizing the water supply if needed. Example of firefight emergency, and at the same time reducing dramatically the water losses. The representation of the same container filling up with the hidden losses is much different in this case. It is clear how during low demand the valve will react in decreasing the pressure, so with the same percentage of holes in the pipe we waste a less amount of water, so to speak. The CSA Pilot is equipped Modbus communication protocol with an handy display that allows the programming on site or from remote of the variation velocity of the stem, adjustable on the base of the stroke, in addition to manual wheel for emergency situation. Many other parameters like and power failure safe positions, excessive torque that can be programmed according to the need of the site.